on 6.4, okay? And actually the homework is listed at the top. So 3 through 17, all 31, 32, and 34 is the homework. Hello, Greta. I'm glad that you found us. We're doing a quick, easy lesson on 6.4. It should be very fast. So that's the goal today, to get you guys what you need to know and on our way. Okay, hello. So we are going to talk about, so on Monday, we talked about similar polygons, right? So similar polygons basically mean that they have, the angles are equal to each other and that the sides are proportional to each other. So that it doesn't mean congruent. Congruent means equal to each other, right? Similar means that they share basically the same shape, but that they are proportional to each other. So it's basically like shrinking or enlarging one polygon to another. So we're that was on Monday. We talked about that. I think everybody got that. Today, what we're going to talk about is we're going to get more specific. So we're going to take the triangle, which is the type of polygon, and talk about proving that two triangles are similar to each other. So we're not proving that the triangles are congruent, we're proving that they're similar. And so we have less stringent rules if we just want to get them, if we want to prove that they're similar versus if they're congruent. Because if they're congruent, all of the sides have to be the same and all the angles have to be the same. If they're similar, they just have to have the same angles and their sides have to be proportional to each other. Okay, so we're going to start with a postulate, and pretty much the whole section is just this postulate. So if you remember this, then you should be good to go. So this is postulate 22. It is the angle-angle similarity postulate. So this says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Ta-da! So basically, you see you have triangle JKL and triangle XYZ. And we know that angle K is congruent to angle Y and angle J is congruent to angle X. So since we have two angles, an angle in each, two angles in each triangle are congruent to two angles of the other triangle, then we can conclude, that the two triangles are similar to each other. Okay, so this triangle is similar to this triangle. And I think this makes sense because if you know two angles of one triangle, you can always find the third one, right? What do all the angles of a triangle add up to? Suspense, right? 180 degrees, there you go, 180 degrees. So for example, if we knew that this was 20 and this is 60, 20 plus 60 is 80. So that would make this 100 degrees. Now that's not true because this would be your 100-degree one. But yes, so let's say 20 and 100, and we would know this is 60. Then we would also know this is also 20, and this is the same angle. And so all three angles would basically be equal to each other. If you have two angles that are equal to each other in another triangle, that basically means all three angles are equal to each other, right? Okay, makes sense? I think intuitively it just kind of makes sense, like, oh, all right. So let's just do a couple examples. Like I said, this is a very quick section, so that's why I'm doing it online. I apologize to everyone who can't get into the link. How do I get rid of this thing on my screen? Nope, that's not what I want. Whoa, move you out of the way. There we go. Okay. So here we go. We have at the top, we have some triangles, right? We have PRQ and FGH. So PRQ has angles of 71 and 78. Oh, I'm sorry. What we're trying to do is we're trying to figure out if the triangles are similar. And if they are similar, we're trying to write a similarity statement. So I'll show you what that means. So let's figure out if they are similar first. Okay, so this angle, let's just look at PR and Q. We have 71 and 78. So if we want to figure out what angle Q is, just to write it out and be super duper uber clear, right? We know that the measure of angle P plus the measure of angle R plus the measure of angle Q is going to equal 180 degrees, right? So P is 71 plus 78 plus the measure of angle Q. I wish I could write nicer on here. Equals 180 degrees. Okay. If we subtract 71 and 78 from both sides, we get that Q is equal to 31 degrees. Okay. So this is 31 degrees. All right, so now I've got that triangle, I got PRQ figured out. Now I'm going to shift over to FGH. So FGH gives us two angles. They tell us that angle F is 78 degrees and angle G is 31 degrees. And we've actually already done the math here, and we actually don't even need to do the math because we just need two angles that are congruent to each other. Two angles that are, congruent, that's the right word. If we have two angles that are congruent to each other in each triangle, then we know that the two triangles are similar. Okay, thank you, Kirsten. Thank you for being my go-between. Okay, so we have Q, right? Oh, I wanted a different color. Angle Q is congruent to angle G, and angle R is congruent to angle F. That should be two lines there. So if I wanted to write a similarity statement, I would say that triangle QRP is similar, and now this is where you have to pay attention. Q, right? Angle Q corresponds to angle G. So it would correspond in the same writing when you write out the triangle. Q has to go in the same spot as G. And R and F are the same angle. So where R is, we put F. And that leaves SAD P and H. So GFH. So we would say triangle QRP is similar to triangle GFH. Okay. So that's all this section is figuring out, are my triangles similar? So let's go through these last couple, and that's pretty much it. So number 2, we have PRQ, again, they couldn't name it a different one, and GHF. All right, so we're starting off good because right now we have angle P and angle H are congruent to each other, right? These are both 27 degrees. So we have one set of angles that are congruent to each other. No, I just wrote over top of 27. These two are congruent to each other. So that's a good start. Now we can figure out what angle G and angle R obviously do not match each other. So we can figure out what one of the other angles is. So let's actually go with the bottom triangle. Okay, so we have basically the measure of angle H plus G plus F is 180 degrees. So we have 27 degrees plus 110 degrees plus the measure of angle F equals 180. Ugh. Don't like that writing. Here we go. Let's make it a little bigger and nicer. $180. Okay, so if I add 27 and 110 together, I get 137, and I subtract that from 180, and I get, let's see, 53. No, that's not right. Is that right? 110 minus 180. I should have my calculator up here. 70, 60, 50. All right, I'm busting out the calculator today. I feel like I'm doing something slightly wrong here. Wow, that's a big calculator. Okay. (180 degrees minus 110 degrees minus 27 degrees is 43. That's what I was thinking. I'm like, what? I can't be right. All right, so sorry if I lost you in my calculations here, but we figured out that the measure of angle F, is 43 degrees down here. 43 degrees down here. So what do you think? Are these similar? Nope, because 43 does not match, 53, so we would say these are not similar. All right, so a little more tricky at the bottom are these next two, but really not that big a deal, okay? So you'll see here that it says, show the two triangles are similar. Whoa, that's not what I was trying to do. Show the two triangles are similar. So we have triangle RTV. So RTV is actually the little guy here. RTV. Okay, and RQS. RQS, we'll make in blue. RQS. Okay, not too terrible. So we need to show that they're similar. Well, we know, just based off of looking at this, right, that both these angles are 49 degrees. So angle Q and angle T are congruent to each other. So we have one angle in each triangle that's congruent. What about another angle? What other angle could we use? What about angle R at the top? They both share angle R. So does angle R equal angle R? For sure, right? That's just kind of a given. Angle R equals angle R. So we have two, and that's the reflexive property, right? So we have that measure of angle Q equals the measure of angle RTV, and we have that angle R equals angle R, so we can say that triangle RTV is similar, right? Not congruent, just similar to RQS. RTV is similar to RQS, and they're written in the right order. Okay, now we have LMN and NOP. Okay, so we have L, and let's pay attention to which way we draw it. LMN. I'm making the triangles like squishy. And NOP. Okay. Now, if I didn't draw over top of those, you would see that angle L and angle N are actually already marked as congruent to each other. So we have one set of angles that are congruent to each other. So now we need another set. So the answer to the second one lies in the fact that NM and OP are parallel to each other. So if you remember back to when we learned all about parallel lines and when they intersected transversal, we said that when two parallel lines intersect a transversal, then the angles they form, the corresponding angles, are equal to each other. So what I mean by that is this is a parallel line here. This is parallel to this line, right? And they're both cut by LP. So when they're cut by the same transversal, then we can say that this angle is congruent to this angle because they are corresponding angles of the corresponding angle postulate. So now we have, I'm trying to draw two lines here. There we go. We have two angles in each triangle that are congruent to each other, so we can say LMN is congruent to NOP. Okay. Hi, Greta. I'm sorry for the technology issues. You're back. And we're almost done. How about that? One last problem, and then that's it. And hello to everyone watching on YouTube. I'm sorry. I see that Kirsten said Olivia's watching online. Okay. I don't know why in geometry I feel like we've done lifeguard problems before, so here we go. Here's how you can actually use the side angle similarity postulate. There's a lot of lifeguards. I don't know. Okay, so a lifeguard is standing beside the lifeguard chair on a beach. Here's our lifeguard. Here's his chair. He's a really tall lifeguard, I guess. Oh yeah, the lifeguard is 6 feet 4 inches tall. Tall dude. And he cast a shadow that is 48 inches long. The chair cast a shadow that is 6 feet long. How tall is the chair? These problems always crack me up because if you got out your measuring tape to see how far away the guy was, you could just measure the height of the chair. But, you know, we're going to be smarter than that, and we're going to figure out how tall the chair is based off of angle similarity. So this awesome picture that we have here, maybe I can make it bigger. Let's see. Trying to make my screen bigger, but it's not letting me. So this awesome picture that we have here shows our lifeguard guy and our chair. And we know that hopefully our lifeguard is standing straight up and our chair is standing straight up. So if we do that, we know that they form a right angle with the ground. And right angles are congruent to each other. So voila, we have one angle that's already congruent to each other, right? Also, we hope that the sun is shining from the same location for both the person and the chair, right? We will assume that this is true. The sun is up here in the sky, making shadows over the lifeguard and the chair, and the guy in the the guy in the lifeguard chair are both. We're going to assume when the sun goes over the guy in the lifeguard, they make the same angle because the sun rays are coming in at the same angle. So you can see here it's marked really little, but this angle right here is congruent to this angle right here. Okay, so now we know that these two triangles formed by the lifeguard and the chair are similar to each other. So this is kind of the new piece of information, not really new. We just have to pull this in from Monday, okay? We know that the two triangles are similar. So similar triangles have the same angles and we know that their sides are proportional to each other. All right, so that means that this dude who is 6 foot 4 inches, I'm going to write it in an improper way here. I'm going to say he's 6 foot 4 inches tall, right? Dude who's 6 foot 4 inches tall is proportional to the height of the chair, which is X. Okay. We also know that the shadows equal each other. So the lifeguard dude, right? He's 48. His shadow is 48 inches. And the chair's shadow is 6 feet. So the one kind of piece of information that you need to pull in from Monday is that, and from today we know that the triangles are similar, and from Monday we know if two triangles are similar, that means that their sides are proportional to each other. Okay. Now what we have here is a proportion that we can solve. We can solve for X, but it's kind of a mess because right now we have inches and feet all mixed together. So you'll see here we have feet, here we have inches, here we have feet and inches. So we need to basically like convert either all to feet or all to inches. So I am proposing that we convert it all to inches. Let's convert it all to inches. Okay, so we have 6 foot 4 inches. We'll bust out my calculator since my brain is not working quickly today. So 6 feet times 12 inches plus 4 more inches is 76 inches tall. So lifeguard is 76 inches, okay, over 48 inches equals X feet over, and then we just did 6 times 12 is 72 inches. And I don't know why I just wrote feet right there. This should also be inches in the top. Now we're all in inches, and remember, when you solve for X, you're going to be in inches. Okay, so now we have a proportion and everything's happy and in the right, the same units. So to solve our proportion, we're going to cross multiply, right? We're going to do 48 times X equals 76 times 72. So 48X equals 76 times 72. 76 times 72. 5,472. 72. Okay. Then we're going to divide both sides by 48. And we end up with X equals, divide by 48, 114 inches. So the lifeguard chair is 114 inches tall. This is our X up here, right? It's 114 inches tall. If we wanted to convert that to feet, we're going to divide by 12, right? I don't think it's going to divide out nicely. Oh, there we go. So it's 114 inches tall, or 9.5 feet tall. So now, last thing is look at the picture, look at the problem. Is that reasonable to assume that a lifeguard chair is about 9.5 feet tall? I'd say so. If you, for example, got that the lifeguard chair was 114 feet tall, then you might be a little worried. That'd be a little crazy. Okay, so that's what I wanted to do today. It's a quick, easy section. I'll probably do a little bit more on Monday. Again, at the end of the call here, let me put up on the screen. The homework is 3 through 17 all, 31, 32, and 34. And again, I apologize. I don't know what I'm going to do with technology stuff, but thank you guys for sticking with me, and I will talk to you on Monday. Bye.